Hello everyone. Today let's solve the problem number 78, subsets. So you can just go through the question and you can just try to understand the question with the help of example that they have given or the examples that they have given. So I'll just summarize the question for you so that it will be easier to understand. Let's understand the question first. So what the question states here, we are given an unique integer array, nothing but nums here. You can clearly see unique integer array nums, and we need to generate all the possible subsets. So we have to generate all the possible subsets, and we have to keep two things in mind. Two requirements they have given, nothing but the solution should not contain duplicate subsets. So here the duplicate subsets should not exist. That is one thing. And it can be returned in any order. We can return the solution in any order. Order doesn't matter, and it cannot contain duplicate subsets. These two things we have to keep in mind. So here you can clearly see for the 1, 2, 3, we have to return all the possible combinations of all the possible subsets. Here they have given empty array 1, 2, 1, 2, 3, 1, 2, 3, 2, 3, and 1, 2, 3. Only thing is we shouldn't return the duplicate subsets. That we need to keep in mind, and it can be of any order, right? So for 0 we have only one element. Here always remember one thing, a empty subset, I mean empty element or the empty array, this one, that is also considered as subset here. This one, that one you have to keep in mind. So this is one thing. I hope the question is completely clear. Let's discuss the approach step by step, followed by this one, edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. First thing is we have to go with the approach, right? So let's discuss the approach by taking the first example. I'll just consider this example. So here let's go with the let's discuss the approach step by step by considering the example that they have given in the question. So we'll be making use of backtracking. Just keep this in mind. We'll be making use of the backtracking here for this particular problem. So we will make two choices at each step. One is include and other one is exclude. So first thing is we'll be making use of backtracking, making two choices at each step. One is include and exclude. Include or exclude the current element. So here the output will be, the final output will be the elements that are present in the include at each step. This we have to remember. Let's consider 1, 2, 3 is the element that we have here. Initially, let's go step by step. Let's consider the element 1. Initially, let's go with the empty subset. Empty subset is a subset. So the elements, this one, array with no elements is considered as an empty subset, right? So that one, let's consider that one at the first step. So I'll just come here, first step, let's start with the empty subset here. This one I'll just give here include. This one will be exclude. So first element we have is 1 here. Let's consider 1, right? So in this case, include 1, exclude 2 here. Exclude 1 here. So this will be empty when we include 1. When we exclude 1, this will be empty. When we include 1, this contains 1, right? Let's move on to the index 1, right? At index 1, we have the element 2, right? So this is the second step at index 1. So at index 1, we have the element 2 here. You can clearly see. First, as we are backtracking, we will go with every possible combination starting from 1, right? So for 1, we have to consider here. For 1, right? We are considering for 1, this one. Same steps, include and exclude. This at index 1, we have 2, right? So for 1, we have to consider. For 1, it will be 1, 2 when we are including 2 here and excluding 2 here. When we exclude 2, it will be only 1. So for 1, we considered. For empty array, we have to consider again include 2, exclude 2 here. This one will be 2 and this one will be empty when we exclude, right? So this is fine. Let's move on with the next step. nothing but to the at index 2, the final one, at index 2. What we have at the index 2 here? We have this one, 3 at the index 2. Initially, as usual, we'll be considering for 1 comma 2 for 1 and for the empty array. These three things we have to consider, right? Now we have for 1 comma 2 we need to consider for this one, yeah, for 1 comma 2 for 1 for 2 and for empty array. So for these four things we need to consider, right? So let me come here. For 1 comma 2 include, what's the number? 3. We have the element 3, right? Include 3, exclude 3 here. So here in this case, when we include, it becomes 1 2 3, exclude, then it becomes only 1 comma 2. Next, let's go with for 1. Same thing, same step, include 3, exclude 3. So here it will be 1. I mean, sorry, we have 1, right? We are including 3, 1 comma 3. Excluding 3 will be only 1. This is fine. Next, we'll be considering for 2. Same steps. So let me write this quickly. Include and exclude 3 here. This one will be 2 comma 3 and this one will be only 2. The final one we have to consider for the empty array as well. So I'll just consider here itself. Include 3, exclude 3 here. This one becomes only 3. This one becomes empty. This stays empty itself. So we have to consider all the things that we have, all the elements that we have considered in the include, not the exclude. Exclude one, we will exclude that one. So first we have 1 within the include. This one we will consider here. So let me come this one. First we'll be going with the empty subset or the empty array that is considered as a subset. First thing was 1. We saw that one. And the second one at include we have 1 comma 2, and for this one include we have 2. 1 comma 2 and 2 we will consider. So let me consider here 1 comma 2 and 2, right? So let me come this one. Let me come to the page 3 here. This one include we have 1 comma 2 comma 3. So here 1 comma 2 comma 3. This is fine. Next include we have 1 comma 3, 2 comma 3, 3. 1 comma 3, 2 comma 3, and finally we have 3. So this is the output that we got, and this is same as the output they have given in the example. Here you can clearly see order might be different. We can get the output in any order. They have clearly given in the question that order doesn't matter here. Empty array 1 1 2 2 3 1 3 2 3 1 2 3. That's what they have given here. The same thing, 1 1 2 2 1 2 3 1 3 2 3 3. Same thing, right? So I hope the approach is completely clear. Here we are making use of recursive backtracking, right? Or the backtracking. So I hope the approach is completely clear. We discussed the same thing with the example that they have given in the question. So next, let's consider all the edge cases one by one and then finally write the code. So the first edge case, let's go with the minimum input case. So I'll just go with minimum input case here. So for this one, let me consider input 0 or any element. So only one element, minimum input case, right? So you can just consider any element, but it should have the length 1. So output will be here. So let me remove this one. Output will be in this case empty array. We have to consider empty array is a subset, right? So this one and 0. This is for the condition minimum input case, right? So for the second one, let's consider all positive numbers. This is fine. All positive numbers. Input, let's consider 1 comma 2 comma 3, and output will be here in this case empty array 1. Same thing, the example one, right? This one. You can just visualize or you can just write out in the same thing that I have showed. The same thing, the output that I'll write here directly. So this will be 1, 2, 3, 1, 3, 2, 3, and finally 1, 2, 3. So these are the subset. This will be the output. This is for the condition all positive numbers. Let's move on with the third edge case. Nothing but includes negative integers or negative numbers here. This is fine. This has to include negative numbers. So I'll just consider here -1, 0, and 1 as input. So the output will be here in this case. You can just try it out in the same way that I showed for the example. Output will be -1, 0, -1, 0, 1. This one will be -1, 1, 0, 1, and finally -1, 0, 1. This is fine. This is the output that we got. So this is for the condition includes negative numbers. These three edge cases we need to keep in mind. First edge case was for the minimum input case. We saw this one. Second edge case was for all the positive numbers. We saw this one. Third one was for it includes negative numbers as well in the input. We saw this one as this is the output. So I hope all the three edge cases are clear. Now let's start writing the code, right? And discuss the complexities of the code that we have written. Let's start writing the code. So initially, I'll just consider here a result variable. We have to store all the subsets, right? For that reason, I have just considered result variable. Also, we have to store the current subset that is being formed. For that one, I'll just make use of the variable named subset and initialize this one to the empty array as well. So initialization part is complete. Next step, let's go with the recursive backtracking function. So I'll just make use of backtrack here. Let me pass the parameter I. This is fine. We're just going with the recursive backtracking here. Just keep this in mind. So what was the base case that we had discussed? If we processed all the elements, we have to save the subset. So here in this case, I can just give if I equals length of the number. So if we have processed all the elements means we are considering the length, right? Nothing but in this case we have nums as the parameter. So if we have processed this one array, right? Nums is nothing but the integer array. So here I equals nums length of the nums. That means if we have processed all the elements, we have to save the subset. To save the subset, we can just store a copy of the subset, right? For storing the copy of the subset, let's make use of the push here. So this one, what we are saving? We are saving the subset. So I'll just give here subset. This is fine. This one. We have initialized this one to the empty array initially, right? Subset. So I hope this is clear. Next step is we don't have to return anything. So I'll just give here return. This is fine. So this is the base case that we considered. So if we processed all the elements, we have to save the subset. So that's what we did here. And in the approach, if you remember correctly, we had two choices, right? We went with two choices. One is include and one is exclude. So first, let's consider include here. Let me give here subset dot push here of nums of I. So what we are doing here, we are adding the current element to the subset here in this line. So after adding the current element to the subset, we have to move to the next element, right? So current element we need to add to the subset and then next we have to check or we have to move to the next element. For moving to the next element, I'll just come here. I'll just make use of the function name backtrack. Let me give here backtrack I plus 1 just to move to the next function. This is for the choice 1 or include, if you remember the approach correctly. Then let's move to the choice 2, nothing but exclude. We are excluding iterative value of the nums. Here we are including the iterative value of the nums. Here we have to exclude the iterative value of the nums, right? So how can we do that? I'll just give here subset dot pop here. In this case, we are removing the last element, nothing but backtracking. We are just backtracking here. here what we were doing, we were adding the current element to the subset in this case, and we are moving to the next element. Here in the exclude, we are removing the last element and we have to move to the next element without including it because we are removing. So after removing the element, we should not include the same element, right? So we are removing the last element and we have to move to the next element without including it. In this case, I'll just come. This will be same thing. Backtrack function I'm using. This will be same thing. I plus 1. This is not ui plus 1. I plus 1. This is fine. Right. So here, as we are making use of the iffy or this one, immediately invoke function expression. Here you can see the syntax. We have started with the parenthesis, right? We have to include 0 here in this case. So we are starting from the index 0, right? So that is the reason I have given 0. Again, I'm telling, if you didn't get this, why I have included 0 here, we are starting from the index 0. So if you have seen the approach correctly, we started from the index 0 and we had the element 1 at index 0, right? 1, 2, 3 we consider the elements within the array. So first element we are including here, so as we are starting from the 0. I hope this is clear. So next final step here, we have to return all the generated subsets that will be stored in the result, right? So I'll just return here a result. So I hope this is clear. So let me format this one and run the code. So you can clearly see the sample test cases are getting passed here. So let me hit the submit button now. So here you can clearly see all the test cases are getting passed, right? So the code works absolutely correct in this case. So what shall we do now? Let's quickly discuss the time complexity and the space complexity of the code that we have written. So the approach that we went with here is recursive backtracking or the backtracking that we know, right? So this is one thing. And so what will be the time complexity here? Overall time complexity would be big O of 2 to the power of n. So I can just write this one in this way. So this will be big O of 2 to the power of n. Why here the time complexity is big O of 2 to the power of n? Because each element we have, each element has two choices that we know, right? Include and exclude. Each element is having two choices, include or exclude. So overall time complexity would be 2 to the power of n. So what will be the space complexity here? Overall space complexity would be here big O of n. Why here the overall space complexity is big O of n? Because we are making use of the recursive stack, nothing but recursive backtracking we went with, right? So approach. So we are making use of the recursive stack and recursive stack depth at most is n. We know that. So the space complexity would be big O of n here in this case. So I hope this is clear. So the overall time complexity is big O of 2 to the power of n. And the overall space complexity here is big O of n. I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.